So if we're going to write or balance nuclear equations, we have to make sure that we're doing it properly. I've mentioned this as I've pointed to them, but you're going to use the nuclide symbol. Okay, well, that's your letters for whatever element it is. And you're going to use superscripts for mass and subscripts for the atomic numbers. So you really have the same piece of information there in two places, but it's very helpful to have it there. So we go ahead and put the atomic number as well as the symbol. The sums of the mass numbers, those are the ones up top, of the particles on the left of the arrow have to equal the sum of the mass numbers on the right. And the same thing with the subscripts. The ones on the left of the arrow have to equal the ones on the right of the arrow. So on number 1 here, we are going to try to write this down. This says lead 214. Well, okay, here's a 214. I know that's the mass number. They told me it was lead. And then it says decays 2. So that's my arrow, is decays 2. Bismuth, okay, Bi, and 214. Oh, and then oh, this is 2 of them. Okay, so this is going to be the first one, and then we'll do a second one. So this is the first one. I have to go look up these numbers on my periodic table because they're high enough. I don't have them memorized. I look this up and I find out this is lead that is atomic number 82, and bismuth is atomic number 83. So then when I look at this, I'm like, okay, 82 equals 83. Well, this has got to be a -1 then. And 214 equals 214 and 0. And then I will look at this and say, oh, no mass and a negative charge. Well, that's a beta particle or an electron. So that's the first one. Now it says, and then to thallium-210. That doesn't mean that this is going to go to thallium-210. It means that what this was will now be what I start with. So I'll start with the bismuth that's at element 83 and has a mass of 214. And it says it continues to decay and it forms thallium, which you might think is TH, but no, Thor is already there. So it's TL, all right? And that's a 210. And then you end up having to go look this guy up and you find out that its number is 81. So how did that decay? 83 equals 81 plus 2. 214 equals 210 plus 4. Oh, now I recognize that. That's your alpha particle. So I had a beta decay for the first one, and I had an alpha decay for the second one. And I'm done with that.